everybody, this is Miss Bufford, and in this video we're going to talk about significant figures. So your learning goals are to be able to explain why significant figures are important in science, and to be able to perform calculations and record an answer with the correct number of significant figures, or significant digits as we'll say. So what are significant digits, and why are they important in science? So these are important when we're dealing with measurements in science, because all measurements contain some amount of uncertainty, and which, remember, that comes from that last estimated digit in every measurement. And keeping track of this uncertainty throughout calculations allows us to know how much uncertainty or error there is in a result, and therefore allows us to limit that amount of error in our result as much as possible. All right, so which digits in a measurement are considered significant? There are some rules for following or for determining that, and three major ones. These first three up here are the major rules. So we've got all non-zero digits are significant, so any digit between 1 and 9. Zeros that fall between two non-zero digits, so they're kind of sandwiched in there like an Oreo. And then numbers containing a decimal. All of the zeros at the end of that are going to be significant. None of the zeros in the front, just the ones at the end, if there's a decimal. And then this last rule just applies to numbers that are written in scientific notation, which we'll learn about in the next building block. Our coefficient in our number in scientific notation contains all of the significant digits for that number. So let's look at a little bit more of a practical way of applying these rules when we're trying to determine what numbers are significant and which ones are not. So this is how to identify sig figs, or significant digits, in a measurement. So the first thing you want to do is you want to draw a box around all non-zero digits, including any of those zeros that are in between the two non-zero digits, like this one right here. So there's our box. Those are all the non-zero digits. The second step is, if there's a decimal present in the number, then you want to draw a box around the trailing zeros. And the trailing zeros are the ones always at the end of the number that come after the number. And then the third rule, all the digits that are inside a box are significant. So at this point, you just want to go through and count all of them. And in this case, we've got 7 significant digits in our example measurement. And then one other thing to always remember, that the numbers in the coefficient in a number in scientific notation are all going to be significant digits. So let's go ahead and do some practice counting significant digits. So what I'd like for you to do is go ahead and pause the video for just a minute and see if you can determine how many significant digits are in each one of these numbers, and then we will talk about them here in just a second. All right, so that first number up there at the top, if we were to follow our rules, so any non-zero digits are significant, and I'm going to draw a box around them, and if there are zeros in between them, those are going to get included in that box. All right, and then the second rule was that if there's a decimal in that number, then the zeros at the end get a box, and there is a decimal, so I'm going to put a box around these, and which means that they're all significant. So 1, 2, 3, 4, 5, 6, 7. I have 7 significant digits there. Let's go to the next one. I'm going to draw my box around all my non-zero digits. And I have a decimal, so this gets a box as well. So again, they're all significant. 1, 2, 3, 4, 5, 6. 6 sig figs. All right, all my non-zero digits get a box here, and there's no decimal, so I'm not going to put a box around those last 2 zeros. So in this case, I just have 1 sig fig. Okay, Next one, so I'm going to write a box around all my non-zero digits, and this number does have a decimal, but there are no zeros at the end of it, so I'm done drawing my boxes, and now I have 3 significant digits for that one. And then this one right here, here's my box for this non-zero digit, and there is a decimal here, so I'm going to draw my box around these last 3, and that means I have 4 significant digits in this number right here. All right. So now we need to talk about how to perform calculations with significant digits. And when we do these calculations, you just want to keep in mind that we're just trying to limit the amount of error that we end up with in our answer when we are paying attention to significant digits. And so there are different rules for when we add and subtract versus when we're multiplying and dividing. So this slide right here has all the rules for addition and subtraction. So when you're adding or subtracting measurements and you're trying to keep track of significant digits, you want to first perform the calculation. So just go ahead and plug it into your calculator or however you're going to solve it. Just do the normal calculation and get your calculator answer. Step 2 is to look at those numbers in the problem and find the least precise value. And remember that that's the one that has the fewest decimal places in it. And then the third step is to round your final answer to have the same number of decimal places as your least precise value from the problem. So let's go ahead on the next slide and take a look at an example problem. All right, so here I have 200 plus 20.3. And the big question here is, we'll come back and answer this first question, so about rounding the result. But step 1 here is to solve the problem, which we did. And then step 2 is to find the least precise value. And remember that when we're adding and subtracting, it's all about the number of decimal places we have. And so we're looking for the one that has the fewest decimal places, which would be 200 right here. This has it has 0 decimal places. And so we want to round our final number to have the same number of decimal places as that. So we want to round away this 3. So goodbye 3. All right, and let me cross it out again. I'm on a new slide here. So our final answer is 220. So we end up with 220 for our final answer. So let's go back to that question, why must we round the result? And why can't we leave the answer as is? So if you were looking at this example and wondering what these red lines here were, remember that the last digit in every measurement is our estimated digit. And if you take a look at, if we were to add these together, we end up with 2 digits that contain error in our final answer. So these are both estimates, and we can't have more than one estimated digit in our final answer. So what we want to do is we want to round that so that we end up with just one estimated digit right here in our final answer, because we want to limit the amount of error that we have. If we kept this as 220.3, then it would naturally be assumed by other people who didn't see our calculation that this 3 was our estimated digit and that this was a certain value, which it is not. So that is why we have to round this here. Okay? So the first one's already showing your answers. Remember, you want to go ahead and get your calculator answer first. And then you want to round that to have the same number of decimal places as the one that had the fewest, which in this case it's that one. So we're not going to have any decimal places, so we're going to round those away. If that number right here is 5 or greater, then it will cause the number next to it to round up. So just remember that rule from math class. And then once you've gotten your final answer, just count the number of significant digits in that number and report that as your third answer. So go ahead and pause the video and do these next 3 example problems, and then we'll talk about them. Okay, so let's go ahead and talk about the one in the purple box. We have 200 plus 0.001. So my calculator answer here is 200.001. And I know that 200 has 0 decimal places, so my final answer is going to end up having 0 decimal places. So I'm going to be left with 200. And if I were to apply the rules for determining sig figs to this number, you would see that I could only put a box around that too, and I'd end up with one significant figure, one significant digit. Okay, let's go ahead and do this other one. So we've got 20,549 minus 12,901. So go ahead and pause the video again and come up with your answer, and then we'll talk about it here in just a minute. All right, so if I plug this into my calculator, here's my calculator answer. Neither one of these numbers have decimal places, so they have the same number of decimal places. So we just need to make sure our answer has no decimal places, which it's already decimal free. So there we go. And then if I wanted to count the number of significant digits, these are all non-zero digits, so they're all significant, and I have 4 sig figs in that answer. All right, and then for this last one down here, I've got 499.0 minus 200.5. And so my calculator answer is right here, and these both have 1 decimal place. So I don't have to do any rounding. I can leave that number as it is because it only has 1 decimal place. And then these are all non-zero digits, so I'm going to end up with 4 significant digits there. All right, now let's talk about the rules for multiplication and division. These are a little bit different than the rules for addition and subtraction. And when you're in the middle of doing all these calculations on a worksheet or in a quiz, it's really easy to get the rules confused. So you want to really make sure that you're understanding the difference between the 2 sets of rules. So we're multiplying and dividing here. Just like the other one, we're going to go ahead and perform the calculation. Just go ahead and get your calculator answer. And then you want to look at the numbers that were in that problem that we started with. And you want to find the one that has the fewest significant digits. So with the other set of rules, we looked at decimal places. Now we're looking at the fewest overall significant digits. And then we want to round our result to have the same number of significant digits as the number that we started with that had the fewest. So let's go ahead and look at an example of that. All right, so here I've got 20.3 times 22. And what I want to do, I want to just go ahead and get my calculator answer, which I've done down here. And now I want to find the number up here that has the fewest number of significant figures or significant digits, and that's this one right here, 22. It only has 2 significant digits, and this one has 3. Okay, so we're looking at 22. We want our final answer to have 2 significant digits. So what I need to do is I need to round this so that it only has 2 sig figs. And now the best way to round a number when you're trying to end up with a certain number of significant digits is to start over here at the beginning of the number and count. I only need 2 sig figs. I'm going to have 1, 2. So this place value right here, that's going to be the last place value where I'm allowed to have a significant digit. Everything else has to become insignificant. And so what I'm going to do is I'm going to look to the next place value, and if it's 5 or greater, then I'm going to round this 4 up. Okay, so I end with, that's 6, causing the 4 to round up. I end up with a final answer of 450. And if I apply my sig fig rules, then I'm only going to be putting a box around these 2 digits right here. That 0 is not significant because there's no decimal in that number. I'm not going to put a box around it. And so there we go. There's my answer with 2 significant digits. All right, so let's go ahead and do a little bit of practice. So go ahead and pause the video and see if you can work these problems out real quick, and then we'll come back and talk about them here in just a second. All right, so let's go ahead and take a look at that first one. So here is my calculator answer right here. And I can see that I have one significant digit here and I have 4 here. So I need to have only 1 in my answer. So I'm going to start counting at this 7 because I can't count the zeros in front. They don't count when I'm counting sig figs because they're never significant when they're in the front of a number. So there's my first significant digit. I can't have any other sig figs after that. And so I look to the next number right here. That's a 4, so I'm not going to round up that 7. It's not going to cause 7 to round up. And so my answer is 0.07, and that contains one significant digit. All right, so let's do this one. We've got 200.02 times 0.00144. Here is my calculator answer. And in this number right here, if I'm counting sig figs, then I have 5. And if I count my sig figs in this number right here, I only have 3. So I need to have only 3 sig figs in my final answer. So what I'm going to do over here, I'm going to go 1, starting with that 2, 2, 3. And since the next digit is a 0, I'm not going to round anything up. So there's my final answer right there, 0.288. And that is 3 significant digits. All right, so let's go ahead and do this next one. We've got 2,050 divided by 32,920. Here's my calculator answer. And if I'm counting sig figs here, I have 3 here and 4 here. So I only should have 3 sig figs in my final answer. So again, I'm going to start at that first non-zero digit here and count 1, 2, 3. And since this next digit is a 7, that's going to round that up to 3. And I end up with 0.0623, and that's 3 sig figs. All right. And this last one, I have 200.0551 times 499. And I have an extra 0 here on accident. All right, so here's my calculator answer. I count my sig figs. I've got a bunch of sig figs in here, 4, 5, 6, 7 sig figs there, and then only 3 here. So my answer can only have 3. And so I'm going to start with my first non-zero digit in my calculator answer. So I got 1, 2, 3. And since that next number is a 2, it's not going to round up, and I end up with 0.998, and that has 3 significant digits. All right, I hope this video was helpful. If you have any questions, feel free to contact me through email or It's Learning. Thanks for watching Buffered Chemistry. Subscribe to my YouTube channel for more chemistry.